The teaching at Vedantu was amazing. One aspect where Vedantu teaching differed from a normal offline coaching was the attention teachers gave to our doubts. No matter how many times we asked a doubt, the teachers would patiently clear the doubt every single time. And they made learning a very fantastic experience for us.
Hello guys, this is Saurav here and welcome to another session on Chemical Kinetics. This is for grade 12th and this is lecture 6. This session is based on whatever we have done until now in Chemical Kinetics, and we will be discussing second order reaction and nth order reaction in this session. So welcome to this session guys, and I hope you have learned a lot in the previous sessions. And let's start today's session with, let me just see if I can't see your chats. So let's start today's session. So let's see what does the second order reaction and the nth order reaction talks about. Okay, what does the second order reaction and the nth order reaction talks about? So let's always, as I say, that please do like, share and subscribe. Okay, please do like, share and subscribe. And this is what we have done until now. Rate of reaction to ho chuka hai, rate, law, order and molecularity. Zero order, first order, nth order, ye hum log ab aaj khatam kar lenge. Okay, so zero order, first order is already done. Today we will finish nth order reactions and we will take some examples. Next class mein hum log problems le lenge. And the next class will be on problems based on all of these combined. It will be a lovely session. Please do join us for that as well. But आज के session में start करने से पहले just मुझे एक छोटा सा adjustment करने दीजिए. I am not able to see your chats, so let me just. Okay, anyways, if it is not working, don't get panicked. Okay, I'm able to follow everything that you are trying to say. कोशिश मैं कर रहा हूँ कि उतने easily मैं बता सकूँ कि I would be able to gauge your doubts, but since I'm not able to see your chats, I can't help it right now. Let's start today's session with this idea that what is a pseudo unimolecular reaction. In the last session we had talked about a second order reaction, and second order reaction we had discussed two cases. Okay, second order reaction we had discussed two cases. So just a moment. So second order reaction we had discussed two cases. We had talked about a case where rate is proportional to just one reactant whole square. This is for a reaction. This is exclusively for a reaction which has this representation. A changes into products. 2A changing into products. Another is for rate which is proportional to A to the power 1 and B to the power 1. This is for A plus B changing into products. Okay, so when we talk about a pseudo unimolecular reaction, we are taking the second reaction into consideration. हम लोग second reaction के बारे में बात कर रहे हैं. What does the pseudo unimolecular reaction tell us? A pseudo unimolecular reaction is one which is not a first order reaction. Unimolecular का मतलब, what does unimolecular try to tell us? Unimolecular try to tell us that it is a first order reaction. Pseudo unimolecular tries to tell us that it is not a first order reaction visibly, but the rate law or the rate constant that we calculate it will transform into something, it will seem like it is first order. ये first order जैसा होता क्यों है? Suppose you take two reactants and let's say there are two reactants, ester and water, and it is being made to undergo hydrolysis. The hydrolysis reaction results in the formation of acetic acid plus ethyl alcohol. Now, how does this reaction take place? How does this reaction take place? When this reaction occurs, just a moment guys. Okay, so when this reaction occurs, water is taken in a very very large amount. Water को आप देख लीजिए कि यहाँ पे amount कितना लिया गया है, 10 moles is taken, and ester is 0.1 mole. So if ester is 0.1 mole, water is 10 moles. In the beginning of the reaction, acetic acid is not present in the solution, and ethyl alcohol is also not present in the solution. Okay, ethyl alcohol is also not present in the solution. Now what is happening is, after certain time, this being the limiting reagent, this is completely consumed. आपके पास क्या बच रहा है? 9.9 moles of water is being left out, and 0.1 mole of acid and 0.1 mole of ethyl alcohol is 0.1 mole of acid and 0.1 mole of ethyl alcohol is present. Okay, what we can see from here, is that the amount of this which is consumed and amount of this which is formed is very very small as compared to water. देखिए water का amount और इसका amount compare कर लीजिए, तो water का amount जो है बहुत ज़्यादा है compared to the amount of ester that we have taken. So it is very vital to know that whenever we talk about a pseudo unimolecular reaction, we have taken the reaction of this type, A plus B giving rise to products, where B is in excess. Okay, one of the reactant is in excess. Okay, one of the reactant is in excess, the other reactant is less. Okay, one of the reactant is in excess, the other reactant is very very small. Now when we write the rate constant for this reaction, if we write the rate constant for this reaction, the rate constant will be like this: K is equal to 2.303 upon A minus B times T log of B A minus X by A B minus X. Okay, this is what it will look like. Equation इस तरह का आता है. When you solve this differential, when you solve this, dx is equal to K A minus X to the power 1 B minus X to the power 1, you will get this relation. Now A, what is A and B? A and B is the amount of this and amount of this. There are two reactants, A and B represents the amount of the reactants that you have taken initially. Now इससे हो क्या रहा है? What is happening is that we are getting this equation. It's not necessary that ethyl acetate will be A, water will be B. कुछ भी हो सकता है. इसको आप B ले सकते हो, इसको A ले सकते हो. But the equation will look something like this. Now assume that one of the reactant is taken in excess. A is excess. A is very large as compared to B. If A is very large as compared to B, what will happen? That A minus B will be nearly equal to A minus B will be nearly equal to a minus x will be nearly equal to a, this will get cancelled, or a minus b will be nearly equal to a. What I will be getting is an equation which will look like this. K will be equal to 2.303 upon a times t log of b by b minus x. We'll get an equation like this. We'll get an equation like this. If we are gonna get an equation like this, tell me something. What does this rate law equation resemble? This rate law equation resemble the rate law for a first order reaction, and that's the reason when one of the reactant is in excess for a second order reaction, the reaction will look like a first order reaction because the rate constant expression will be like this. Okay? The rate constant expression will be like this. Is that understood? So if this is understood, let's move on to the next thing. Let's talk about nth order reaction. What is a nth order reaction? Okay? What is nth order reaction? nth order reaction will be written like this. nth order मतलब n का मतलब n की कुछ भी वैल्यू हो सकती है. n can have any value. I will take a simple reaction. A changes into products. Okay? Initial concentration is A. This is 0. This is A minus X, and this will be X. In that case, I will write the rate law as this. dx by dt is equal to k a minus x to the power n. Okay, I would get something like this. dx by dt is equal to k a minus x to the power n because it is a nth order reaction. Now when I solve this equation, what would I be getting is this. I would get a relation like this. This is the expression that I would be getting to calculate the rate constant. इसको मैं और simplify करके लिख दे सकता हूँ. I can say that C naught, what you are seeing over here, is the initial concentration. C naught, which is the initial concentration, will be equal to A, and C at a certain time t is equal to A minus X. Okay, C naught at a certain time is A and Ct is A minus X. If we take that into consideration, I will be getting K as equal to 1 upon n minus 1 times t. Okay, 1 upon n minus 1 times t, 1 upon a minus x to the power n minus 1 minus 1 by a to the power n minus 1. I would be getting this. This is gonna be my expression for the rate constant. Now remember, the expression for rate constant will be exactly like this. ये आपका rate constant का expression आ जाएगा. Now can you tell me, this expression for rate constant is not valid for which type of reaction? This expression for rate constant is not valid for which type of reaction? Suppose I put n over here as 0, तो ये हो जाएगा minus 1 upon t. If I place n as equal to 0, if n is equal to 0, what will it become? K will be equal to minus 1 upon t 1 by a to the power a minus x, n minus 1 0, so a minus x to the power 1 by a minus x to the power minus 1 and minus 1 by a to the power minus 1. I would be getting this. Okay. अरे यार n को 0 रखा है हमने. If I have kept n as equal to 0, n का 0 मतलब order is 0. Nth order means n represents the order. N represents the order. Okay, n represents the order. So if I solve this, minus 1 upon t, this will become a minus x minus a. This will get cancelled. So what will I be getting is this. K will be equal to minus and minus x minus 1, that is x by t. Doesn't it look like the rate constant expression for a zero order reaction? Doesn't it look like the rate constant expression for a zero order reaction? So the rate constant expression for a zero order reaction can be calculated directly by placing n is equal to 0 in this equation. However, अगर मैंने n की जगह 1 रख दिया, if I keep n as equal to 1, then this will become 1 by 0, non-determinable. Okay, it's undefined. It will become, k will become undefined. In that case, I cannot use that expression. So this general expression is not valid. So I would say that this expression is not valid for first order reaction. This is not valid for first order reaction. Okay, if it is not valid for first order reaction, let's see, it is valid for all others. It is valid for 0, it is valid for 2, it is valid for 3, but it is not valid for a first order reaction. Okay, next, what is the t half? To calculate t half, to calculate a general expression for t half, I will get this expression. How do I calculate t half? How do I calculate t half? T half would be calculated by considering that concentration at any time is equal to C naught by 2. Can I say this? Concentration at any time is equal to C naught by 2. Half-life means the amount that is present at any instant. When it is half of the initial concentration, the time that it takes to reach to that value is equal to half-life. So I will place Ct as C naught upon 2. So this will become, so in this equation, if I place Ct as C naught upon 2, I would be getting K T, which is equal to 1 by n minus 1, 2 to the power n minus 1 by minus 1 by C naught to the power n minus 1. I'll get this expression. Okay, I'll get this expression. Fine. So this time is t half, and this is, let's say we put k over here. Okay, so I hope this is understood. How do we proceed from here? How do we further proceed from here? It is important to know that what is the relationship between t half and concentration. Okay, what is the relationship between t half and concentration? So can I say, using this expression, that the general relation between t half and concentration is that 1 by concentration initial to the power n minus 1? Can I say this? So t half is inversely proportional to the initial concentration to the power n minus 1. Okay, I hope this is understood. T half is inversely proportional to initial concentration to the power n minus 1. Now, when we say this, let's look at what are the inferences that we can get. So the moment I say that T half is inversely proportional to C naught to the power n minus 1 for a first order reaction. For a first order reaction, n minus 1 will be equal to 0. N minus 1 will be equal to 0, which means T half C to the power 0. So it will not be dependent, on the initial concentration. T half will be independent of the initial concentration. For zero order reaction, n minus 1 will be equal to minus 1, and for that T half will be directly proportional to C naught. So that means if you increase the initial concentration, the T half will also increase, and for second order reaction, n minus 1 will be equal to 1. Okay, n minus 1 will be equal to 1, and T half will be inversely proportional to 1 by C naught. इसका मतलब ये हो गया, if I increase the concentration, the T half will decrease for a second order reaction, which is obviously evident from the T half that we had calculated earlier. Okay, so इसको याद रखिए, this expression is very important. T half is proportional to C naught to the power 1 by C naught to the power n minus 1. Okay, or C naught to the power 1 minus n. Clear? So with this, let's move on to the next thing. There's an example on the board. Okay, there's an example on the board. Let's try to solve this question. Azoisopropane decomposes according to the reaction is found to be first order reaction. If the initial pressure is P naught and the pressure of the mixture at time t is Pt, then the rate constant would be. So हमें rate constant बताना है. I have to write the expression for rate constant by keeping in mind that the condition that is given over here is initial pressure is P naught, the final pressure at a certain time t is Pt. So how do I do this? So similar questions we had solved in the previous session. Okay, so let's say this is reactant A, which is gaseous, and this is product B, N2 is product B, which is gaseous, and C6H14 is product C, which is also gaseous. So there are three gaseous entities. One is the reactant, the other two are products. कैसे solve करना है इसको? Initial pressure is given as P naught. This is 0 and this is 0. Pressure after certain time t is given as Pt. So this will be written as P naught minus x. This will be x and this will be x. हम इसको ये लिख देंगे. Okay. Now, what is given? The initial pressure is P naught. So P naught is similar to A. P naught is similar to A because that represents the initial concentration, and P naught plus X is Pt, and X is equal to Pt minus P naught. Okay, X is equal to Pt minus P naught. Why I am writing P naught plus X is equal to Pt? Because initial pressure is this and the pressure of the mixture. So ये total mixture का जो pressure है, this is equal to Pt. Okay, the total mixture's pressure is equal to Pt. Clear? With that in mind, so X is known, A is known. I just need to write the expression for rate constant. So the expression for rate constant can be written as like this. The expression for rate constant, so rate constant is K, which is equal to 2.303 upon T log of A by A minus X. So K will be equal to 2.303 upon T log of, what is A? A is P naught, and this is P naught minus X. X is PT minus P naught. So this will simplify to 2.303 upon T and log of P naught by 2 P naught minus PT. Okay, so this will be the expression for K for this question. A similar question we had solved in the previous session as well. So this will be the expression for K. Clear? Chaliye, let's move ahead. A possible mechanism for this reaction is given as this. Okay, now there's a small correction that you have to make over here. This 2, ignore this 2 at this point and put 2 over here. Okay, clear? So this is what has happened. You are given that this reaction takes place in this manner. Okay, the reaction takes place in this manner. आप जब ये reaction लिखते हो, whenever you write the reaction, तो आप ये लिखोगे कि rate is proportional to the reactant to the power its order. Now since the reaction takes place in more than one step, it looks as if the reaction is a non-elementary reaction. So the prefixes would not turn out to be the powers. पहली बात तो ये, prefixes will not become the powers. The prefixes, if are not equal to the power, how are we supposed to solve this question? Let's take the rate determining step. What is the rate determining? The second step is the rate determining step. Okay, so I hope they're saying that this is the rate determining step. I hope that this is the rate determining step. If this is the rate determining step, because this looks like the second step, if the second step is rate determining, मैं इसको ले लेते हैं. Let's say we consider this, that this is the second step. So if this is the second step of the reaction, I will write rate as proportional to H2 to the power 1 N2O2 sorry, second ये हो नहीं सकता. Second will be this, so I will write H2 to the power 1 and N2O to the power 1. Okay, second is the rate determining step. So this is the second step. I guess this is first, this is second, and this is third. ये तीन step में reaction हो रहा है. So second is the rate determining step. I will write it like this, because for the rate determining step, the prefixes is 1 and 1, so the powers will become 1 and 1. Now the point is N2O is not a reactant. बताइए, N2O is not a reactant. NO is the reactant. Clear? NO is the reactant, N2O is not the reactant. So remember, I need to identify a relationship between N2O and NO, which is the reactant. So what is the relationship between N2O and NO? I will write K equilibrium as N2O upon NO whole square. N2O upon NO whole square. So can I say that N2O concentration can be written as K equilibrium times NO square? Okay, I can write K equilibrium times NO square, and finally when I write this in terms of rate constant, it will become rate is equal to rate constant dot equilibrium constant H2 to the power 1 and O to the power 2. Okay, H2 to the power 1 and O to the power 2. So this is the rate law for this reaction. This will be the rate law for this reaction. Clear? So fine. That's all for today. Okay, that's all for today. We will be discussing more. I have taken few examples. Next class we will be discussing about the we'll take some problems on zero order, first order and second order and nth order reactions. So इनको revision करके आइए and we will proceed from here. Okay, so problems होगा and then we will start with collision theory. So please do remember to solve some questions so that next class we will be able to cover these topics pretty easily. Okay, so with this it was a very small session because we had to cover very small part of the chemical kinetics part. Okay, and we will be continuing from here in the next session. And with that note, Saurav Goswami, I'm taking leave, and I hope you guys have a lovely time ahead. Bye bye guys.